Hi students, it's Miss Culver. Can you see me? Hi. So, on our Zoom today, you said that you were having trouble with ellipses. I totally understand. And so I'm gonna go over this with you and do 3 examples and see if that helps you. I did send you a photo. I just want you to know where I put these 2 red stars here. I made a slight mistake here. I had H comma B plus K, and it's K plus B, which is okay, it's the same thing. But right down here where there's a star, in the picture I had A, H, B minus K, and it's K minus B. Okay, now, don't worry too much. We're gonna talk about this here. So, an ellipse, if it has a horizontal major axis, you can see in this picture that the major axis is horizontal in blue, and the minor axis is smaller and it's red. Okay, so let's get a picture of how all this is labeled. Okay, so first of all, notice that the center is always called HK, and that is where the axes cross each other. Notice the ends of the major axis are called vertices. There's a vertex and a vertex. The ends of the minor axis are called covertices, right here and right here. Now the focus is on the inside of the ellipse and is what is actually used to draw the axis if we had string, which I usually do in class. So here's what I want you to know. The major axis in blue is 2 A's long. In other words, this is a length of A, and so is this, right? And that is why one of the vertexes is HK, but it has an A added to the H because it has gone to the right. They added A to the right of H. When you look at the other vertex, right, notice it has an HK in it, but the vertex has gone to the left A, so it's H minus A. Let's look at the covertex. The length of the minor axis is 2 B's, B here and B here. So notice that one of the covertices is HK, but it went up B. Notice that the other covertex is HK, but it went down B. Now, the focus is actually C away from the center. And that's why one focus is HK, but it's gone left C, and HK, and it's gone right C. So notice that all of these points have HK in them, and you just tell how far it moved. Did it move A or B or C, and did it go left, right, or up or down? So here's some things you need to know. The focus is C away from the center on the major axis. The major axis is 2 A's long. The minor axis is 2 B's long. And so what this means is that A is always greater than B, because A is half the length of the major axis and B is half the length of the minor axis, and A is always greater than B. That's actually important to know. Let's go to an ellipse that has a vertical major axis. This won't take as long because all the information at the bottom is the same, only we turned the ellipse. So let's take a look. The center is still HK. The major axis is still blue, and I labeled the vertices in V. And again, notice the top vertex has an HK, but it went up A. The vertex at the bottom is HK, but it went down A. And now the minor axis goes left and right, and that is a length of 2 B's. So notice a covertex is HK, but it wouldn't be to the left, and HK, but it wouldn't be to the right. And the focus, again, those plural is called foci, went up C and down C from the center. So you can see in green, HK went up C, HK went down C. Okay? So here are the equations of ellipses. How do you know when you have an equation of an ellipse if it's horizontal or vertical? Well, it's super easy to tell. Let's look at an equation for a horizontal, an ellipse that has a horizontal major axis. Notice that you have your X and your Y, right? And notice the H is with the X and the K is with the Y. That's the center point. I color-coded it. Underneath the X expression is A squared, and underneath the Y expression is B squared. And it's always equal to 1. There we go, 1. Now, how do I know that the top equation is a horizontal major axis ellipse? Because we know that A is bigger than B, and A is under the X, and X's are horizontal. The vertical major axis equation for an ellipse is exactly the same, except the A squared is under the Y, right? And the Y-axis is vertical, so we know this must be an ellipse that has a vertical major axis. Now here's what you need. A lot of you asked about finding a focus or the foci. You need an equation for that. Notice our two equations for ellipses only have HKs and A's and B's. There's no C. That's related to the foci or the focus. So what you need is this extra little equation. C squared equals A squared minus B squared. Now what I'm gonna do over here, I'm gonna hand the camera to my brother, and we're gonna do 3 examples together. And I think I might try to close this curtain while I hand him the video. And I'm going to have to do one erase, do one erase, do one erase. So you know that you can always go back and you can always pause me if I'm going too fast. Remember in class you were always like, wait, don't erase that. Now you can stop me. So here we go. I'm going to give this to my brother. There you go. You can just hold it straight up like that. And
you don't want me to turn it to the side?
No, thank you. Does that look better? Is there enough light here?
I think it looked better the other way.
Did it look better the other way? Is that okay?
Yeah.
Okay, we'll leave it that way.
They can zoom in, right?
Yeah, they can. All right, students, here we go. Let's see, who had asked for this one? This was Lucas. I think Lucas Shock. This was find the equation of an ellipse from its features. So where the center is the origin, that's 0, 0. Where the foci is plus or minus the square root of 7, comma 0, and the vertices, those are always the major ones, is at the square root, plus or minus the square root of 11 or 0. So class, here's what I do to help myself first. I just plot these points and take a look at it. So here's what I'm gonna do. Now, square roots are not much fun, but that's okay. We'll be okay with it. Okay. Notice that the foci is always C away from the center. I'm just going to put a C here. That might help me later. Now the square root of 7 isn't perfect, but I'm going to call it about 2.5, right? About right there. And here is whoopsie daisy. Whoopsie daisy. Students, what did Miss Culver just do wrong? I plotted the point backward, right? This is the X, and that's 0, sorry. So about 2.5 and about a negative 2.5, I'm gonna put an F on that for foci. All right, the vertices are plus or minus the square root of 11. Again, that's not perfect, but that's okay. Let's call that about 3.5 right here. Vertex and vertex, okay. Now, why did I do this? And here's the origin right here. I did this because here's what I know. The foci always lies on the major axis, and so do the vertices. So I can see this equation is a horizontal major axis. So I'm going to write it. I'm going to write the equation for a horizontal major axis. Right, here's my goal. All right, I need these things. All right, here we go. We need the H, the K, the A, and the B, and we are done. So I know what HK is. That's the center point, and it's 0, 0. There we go. A is the length from the center to a vertex. Oh, and I already have that. That's the square root of 11. Excellent. Okay, I need B. Well, that kind of sucks, doesn't it? Because B is half the length of the minor axis, which goes this way, and I don't have B. But I do have A. Here's A, and I have C. So what do? You use this equation right here. There we go. I'm going to use that equation to get C. I'm going to get B. I'm going to put it right there. Ready? I'm going to write the equation. Okay. We said we have C. It's right there. Okay. All right, beautiful. We said we have A. It's right there. I'm going to put it right there. Okay, now I'm going to solve for B and put it right there, and I'm going to be done. All right, square root of 7 squared, 7. Square root of 11 squared, 11 minus B squared. I'm going to subtract an 11 from both sides. I'm going to multiply both sides by a negative. Ooh, this works out nice. I'm going to take the square root, and I get that B is 2. There we go. There we go. Now, of course, you could just write this as an 11. You could just write that as a 4. Okay? So when you've been given features, Lucas and anyone else, draw yourself a little picture. Decide which equation you have. You need to fill in H, K, A, and B, and you might need this equation down here to get what you need. Okay? So I hope that that helps. I'm going to erase now. Wait, Ms. Culver, don't erase. Oh, you can just stop the video. Okay.